The landscape around me has been shaped by ancient oceans and erupting volcanoes and ice ages. But it's here down in the mud that the real treasures of Britain are buried. Coal, lead, even tin have been pivotal in making Britain what it is today. But there's one mineral that's mined right here that has captured the imagination of both men and women through the ages. It's a mineral with almost magical qualities. It doesn't tarnish, it doesn't fade. It's virtually indestructible. What is it? Gold. Gold. It underpinned our economies, celebrates the pinnacle of our achievements, and epitomises the extremes of luxury and wealth. In the past 10 years, prices have quadrupled, making gold today one of the most sought-after metals on Earth. And what's even more surprising is Britain's gold heritage. From ancient Celtic offerings to the gods, to the wedding bands of modern royals, British gold has played its part. Scotland to Devon, Wales to Northern Ireland, amazingly gold still lies hidden in the rocks. And with Britain on the verge of a new gold rush, I'm on a treasure hunt across the country and back in time, looking to understand how the gold got here and how it continues to shape Britain's landscape and history. Gold has played an important role in Britain for over 4,000 years. It's even thought that the ancient Britons associated its yellow gleam with the rays of the sun. But those ancient Brits could have had no idea how closely linked gold and the sun really are. Because billions of years ago, gold was one of the heavy metals formed during the final moments of a dying star, like our own sun. And the moment it exploded, trillions and trillions of minute gold particles catapulted across the solar system. So the question is, how does gold get from being a newly formed element in a dying star to becoming a precious metal in the rocks of Britain? The answer lies with the birth of the Earth itself. Because after the spectacular demise of the ancient star, the ejected gold particles became trapped inside Earth's newly forming rocks. And while it may have taken millions of years, it left the new Earth literally peppered with gold. But today, nearly all of that precious load is locked deep in the Earth's core. And scientists estimate that over 99% of the planet's gold, that's billions and billions of tons, is far beyond our grasp. Which is a bit of a pity, really, because if we could access it, then we'd be able to coat the surface of the entire planet with 1.5 feet of the stuff, which would be quite pretty, really. But the reality is that most of it is so inaccessible that the amount of gold we can get hold of is tiny, which raises the question, how do we manage to find any at all? But before I can go in search of Britain's gold and understand how it shaped Britain, I first need to get a handle on the titanic geological events that collected those tiny gold particles into mineable deposits. My journey begins in Snowdonia, Wales, where the rugged landscape, shaped by millions of years of violent volcanic activity, hides the clues to the source of Britain's gold. And my first stop is Dinorwig Quarry in North Wales. But I'm not looking for gold. What I'm after is this, a rock that's quite literally shaped the local landscape. Slate, sometimes known as Wales's grey gold. It's played a crucial role in the local economy since Roman times. and it was created in an earth-shattering geological event millions of years ago. An event so huge and momentous, it was responsible for the birth of Britain itself. Though the event wasn't only responsible for shaping the Britain we know today, but also for creating many of our gold deposits. And to help me understand the scale of the forces at work, I've come to meet Cardiff University geologist Hazel Pritchard, whose infectious enthusiasm might have just got the better of her, because it's not gold Hazel's got to show me, but 450 million year old fossilised sea creatures.
Oh, I've just found these. These are graptolites.
These things that are actually in the slate?
Yes, little animal colonies that were in this branch structure.
These graptolites are proof that this area was once an ancient ocean called the Iapetus, and the slate was once a muddy sea floor that was turned into rock by the immense pressure exerted as two continents collided. To turn mud into rock must have taken a phenomenal amount of force.
Absolutely. There were two continents. There was England and Wales and Scotland and Ireland, and they came together and they collided. And the mudstone got squeezed and squashed and flattened to produce this amazing slate.
This continental car crash happened over 400 million years ago, and the effect on the landscape is still obvious today. But what about our gold? Has that been trapped deep in the earth, way out of reach? Well, a lot of it was, but something happened during that great event which concentrated a lot of those rare gold particles into a place where later generations could find and mine them. And to see that, Hazel and I are going further south. Come on, Pep. The closing of the Iapetus Ocean may have left this area rich with slate, but it gifted the rolling hills of South Wales with a much greater prize, creating the perfect conditions to enrich the rocks with gold. This is Dolaucothi Mine, today a popular tourist attraction set deep in the Carmarthenshire countryside. But over 2,000 years ago, this was one of Britain's most productive gold mines. Although, before I can see any evidence of that, Hazel is itching to show me the effect the colliding continents had on the local rocks. God, that's stunning, isn't it?
Yeah, they're really spectacular folds. These are the sediments that were laid down in Iapetus, the muddy shales that became slates in the quarry, and now they've been folded into these magnificent folds.
How long do you think this whole event would have taken?
Oh, tens of millions of years.
As I'm still struggling to fully understand how solid rock can end up folded like paper, Hazel has conveniently organised a little demo, which simulates the effect of the two ancient continents colliding. And while this does feel a bit more like cookery than geology, she seems confident it'll work. What do you call the machine that conducts this experiment?
It's a squeeze box.
A squeeze box.
Oh, that's what I'm going to call it anyway.
So this is simulating what happened 400 odd million years ago.
Yes, when the two continents collided and these horizontal rocks were deformed into what we have above us.
So we've only got two layers here, but they represent all the hundreds of layers that are above our heads.
Yes.
Okay, what do we do next?
Start squeezing. Wow, look at that. So the mountains are building. These two huge continents are colliding, and these horizontal sediments are being folded and faulted and raised into a large mountain.
And it's a process that would have been 1,000,000 times bigger and taken 1,000,000 times longer.
Oh yes, just like the Himalayas today, which are still rising slowly. And here, they're rising slowly. Look at that. It's brilliant.
You really wanted to see this, didn't you?
Yes. A little double fold here, really tight folds, just like the ones we have here in Dolaucothi.
That's extraordinary. You've got exactly the same process going on down there as you had up there. But what we're interested in isn't the folds themselves, but the cracks that formed when the rocks folded over. And to look at those, we need to go in there. This cramped, wet tunnel, called an adit, is just one of dozens that riddle this mine. Extending for several hundred feet into the hillside, it provides a unique insight into the processes that brought the gold to the surface. And this yellowish staining is a sign we're on the right track, as this is the residue of a superheated fluid, a sort of mineral soup that found its way up here from deep within the Earth's crust over 400 million years ago.
The fluids would have been 5 kilometres down. They would have percolated up through the folded rocks, precipitating minerals, and altered the rocks.
So does this mean there could be gold nearby?
Absolutely, and if you look over here, you can see a tunnel,
Yeah.
and you can see some veins that we should go and look at.
And this white rock is what we've been looking for, a vein of quartz.
This would have been precipitated by the hot fluids, which would have been silica-rich, deposited the quartz, but they would have also contained iron, arsenic and gold.
So where all those sedimentary rocks outside were folded, there would have been cracks, and there'd have been a crack here, and through it, all this hot liquid would have come, bearing lots of different sorts of metals.
Yes, exactly.
Including gold.
Yes.
But where is it, I hear you ask? Well, the slightly disappointing thing is that in many cases gold is actually invisible to the naked eye, made up of particles so tiny you could fit about 200 on a pinhead. But believe me, it's there. And this is our first tantalising glimpse of British gold. And there you have it. Invisible gold trapped inside rock-hard quartz veins buried deep underground. And things stayed that way around here for hundreds of millions of years, until that is an invasion by a ruthless and ingenious civilization just over 2,000 years ago. Who would stop at nothing to get at Britain's gold. I'm in South Wales in search of Britain's gold. Welsh gold is considered particularly special. For centuries it was worn by early kings and princes. Even today it's still used for the wedding bands of many members of the modern royal family. Like much of Britain's gold, it was injected into the Earth's crust about 400 million years ago, the result of a huge tectonic clash that also shaped the islands we live on. But you have to fast forward a couple of 100 million years before it begins to be found and used by us humans. And just like the noble art of fishing, hunting for gold is all about knowing where to look. And it was an invading army of Romans who not only discovered the huge amount of gold that there was around here in Dolaucothi, but came up with a very clever idea for getting at it by using this, the River Cothi. By harnessing the river, the Romans had a source of almost unlimited power, allowing them to exploit the rich pickings that lay just beneath their feet. But with the river over 7 miles away from the mine, I've returned to Dolaucothi to meet mining engineer and Roman expert Ed Percy to find out just how they did it. When did the Romans arrive here?
Well, they arrived in, we think, about 74 AD, and they're here for a period of 50 years. So around 126 AD, they abandoned this place. And after that, we don't exactly know what happens, but it's only a very short occupation, really, about 50 years.
How did they use water in order to do the mining?
Well, a lot of it you'll see here. If you look up above you here, there's these banks here. Well, that's a water tank where they were holding water, bringing it from the start of the Cothi 7.5 miles away up the valley there.
The Romans diverted the river by building a complex network of aqueducts or leats. They then used the stored water to expose the gold-rich veins of quartz with a process called hushing.
You burn the topsoil off, take away all the trees, and then release a large quantity of water, and it strips the rock bare, exposing the veins for you to follow down.
How much water?
2.6 million gallons every single day.
That must have completely ripped up the landscape.
Oh, it would have been a massive industrial scar. None of the trees you see here now, it would have been a huge blot on the landscape.
The use of water for mining gold was revolutionary, and its legacy has endured for millennia. Hydraulic mining, which uses high-pressure water jets, fueled the California gold rushes in the 19th century and is still used today to mine the mineral kaolinite here in Britain. 2.5 million gallons of water gushing down the hill. Can you imagine it? It must have been an awesome sight. But they didn't stop when they'd exhausted the gold-rich veins on the surface. No, they started to dig. This is an original Roman tunnel called an adit.
As you're coming up, you'll notice how square this tunnel is.
Dug by hand over 2,000 years ago, it extends for hundreds of feet into the hillside.
If you look at the ceiling, you can actually see the strike marks left 2,000 years ago by the miners.
Fantastic amount of work. But as impressive as the entrance is, it pales compared to this. That's massive, isn't it?
It is. Absolutely massive chamber of quartz has been in here, and they've mined this huge area out. There's a honeycomb of workings in this area.
But they didn't have explosives, so how on earth did they get all the rock out?
There's several things. There's a technique called fire setting, where you set a fire against the rock, make it white hot, douse it with water, and it shatters with explosive force.
With the ore extracted, the rocks were crushed with the aid of heavy water-powered hammers, and the gold was finally separated by panning. Smelted into ingots, the gold from these Welsh hills was instrumental in helping pay for Rome's expanding empire. It's pretty mind-boggling to try and imagine how much work must have gone into extracting all the gold from this place 2,000 years ago, particularly as they didn't have any modern machinery or high explosives. Look at this lot. In order to extract 1 ounce of gold, the Romans would have had to have removed all this, probably more. It's been estimated that they took about 1.5 tons of gold, and in order to do that, they'd have had to have shifted the equivalent of 5.5 million of these trucks of rock. The Romans abandoned the Dolichothi mine after about 50 years, and despite a brief revival in the 19th and 20th centuries, no one has ever found anywhere near as much gold there again. It seems that the Romans knew so much about the local geology that they'd pretty much exhausted the entire deposit. But while the Romans had to work hard for their gold, sometimes nature takes a hand and the gold comes to you via the geology. I'm heading north of the border to the southern uplands, where, just like in South Wales, the events of 400 million years ago created the perfect conditions to deposit a bounty of precious minerals. Welcome to One Lock Head. It's not only Scotland's highest village, but it's slap bang in the middle of an area known as God's Treasure House. It's an area that's rich with copper and lead and zinc, and there's certainly a lot of evidence of lead mining around here. But is there any gold? To answer that, I'm meeting geologist Rob Chapman. So this is it, is it?
This is our place.
Although unlike in Wales, we won't be looking underground, as the gold found here is mostly underwater. As we're looking for what's known as placer gold, which refers not to the type of gold, but rather where it's found. In this case, that's in the gravel and stones on the bed of this river.
Because it's very dense, it sinks down to the bottom.
Yeah.
So we're looking in crevices and crannies where the gold can get in. Once it's in, it doesn't get out. So as long as we can get down, right down to the stream bed and collect the gravel from there, then we should be in with a chance.
Sounds simple enough, and armed with this oversized bike pump, what could go wrong? Bah! It just comes out again.
Give it a bit of a tug,
Yeah.
and then it goes in.
Easy when you know how, I suppose. I was feeling a bit of an idiot up to that moment. The gold originates from quartz veins somewhere in the hills, and through the process of erosion, it's found its way into the river. So, with a bit of luck, it's not just a pan full of stones I've got here, but some flecks of gold too. I thought I saw something glistening. It was just the sunlight. Got quite excited for a moment. But I should know by now, finding gold isn't that easy, and I've still got a little work to do yet. Oh, I'll tell you what, I'm working up a bit of a sweat, I must admit. How do you do this?
Pan underneath the water,
Yeah.
side to side, everything moves. Everything moves, not just the top bit, everything. Let the heavy gold sink to the bottom of the pan.
Yeah. I've seen this in movies. I thought it was just a cliche. I didn't realise it actually did anything. All my heavy stuff seems to have sunk to the top. All this swishing and swirling is, in effect, just replicating the action of the river. The heavier gold tumbles along the riverbed until it reaches calmer, slower water, where it drops out of the stream and settles to the bottom. So the gold that we're panning for here comes from gold-bearing quartz somewhere up in those mountains there, and it gets eroded by glacier action and by the rivers, and comes down the river in little bits, and it lodges in crevices and in the bends of the rivers. In fact, the prospectors say you find gold where the water falls. But do prospectors make any money out of this?
No, there's just not enough around, Tony. It's, there has been in the past, there's been a few gold rushes in Scotland, but there isn't enough to sustain a person to generate an income.
OK, well, I'm not sure I'll be packing up the day job. I do seem to be getting the hang of this. Oh, that's it. Oh, yeah.
Yeah.
I'm rocking.
You're sorted with that. OK.
How do I know if there's any gold in here?
You don't have to try too hard, because there's a bit there, look.
Hey! Really?
Yeah, that's it.
You're not winding me up?
No, I'm not winding you up. Perish of thought. There you are.
I've actually got a bit of gold. I don't think that is going to make my fortune, but it sort of makes it all worthwhile. I always think in these kind of demonstrations no one ever finds anything. I have gold. Gold!
Well, in some cases they're rigged, but this one wasn't.
No, I'm rich beyond my wildest dreams. It's about the size of a blackhead. There he is. This is back-breaking work, but it is a skill worth preserving, because panning like this is just about the simplest way of finding gold. Mind you, I'm not sure my little bit is going to add much to Britain's gold reserves. While I may not have found much gold, over the years Rob's expertise has paid him off much more handsomely.
Once in a lifetime nugget from this area is that guy there.
At today's prices, this nugget would fetch Rob several £100, but I can tell it's worth much more to him than money. What did you feel when you found that?
I thought it was a piece of quartz. It was too big to be a piece of gold.
That's great, isn't it? It's daft, isn't it? They're only minerals, but we're like kids with this stuff.
It's quite tactile stuff. Nothing else is quite that heavy.
Today, it's just enthusiastic amateurs who carry out most of the gold prospecting here. But over 400 miles to the south at the other end of Britain, the local geology has created a deposit that's so valuable and so unusual that it's fueled a new breed of much more determined gold hunters. Isn't that stunning? It's got to be one of my favourite coastlines in the whole of Britain. But even though it doesn't seem to have very much in common with the gold-bearing sites in Wales and Scotland, because of its unique geology, this part of Devon produces gold that's so rare and so beautiful, it's worth more than its weight in gold. And that's actually true. Known as dendritic gold, it takes this beautifully delicate crystalline form. As one of the rarest formations of gold, pieces like this in its raw state are highly collectible and worth thousands of pounds. And just like the Devon coastline, the gold's stunning beauty is all thanks to the area's unique geology. It was first discovered in the early part of the 20th century and made famous by the distinguished mineralogist Sir Arthur Russell. The gold here in Devon, just like in Wales and Scotland, was formed when hot gold-rich fluids percolated up cracks in the limestone rock. But while the process may be the same, the event that triggered the formation is very different. Occurring some 100 million years after the closing of the Iapetus, it blessed Devon with not only this unique gold, but also its trademark coastline. I'm here to find out what happened and what measures are currently being undertaken to protect one of Devon's most desirable treasures. And for this part of the trip, I'm going to need my sea legs. I'm joining mineralogist Alan Hart from London's Natural History Museum on the short trip to a small rocky outcrop known as Hope's Nose. It's here Alan spent the last year and a half studying the gold and its link to the Devon geology.
We've been working really hard on Hope's Nose to try and ascertain how the deposit formed. You know, it's unique in Britain, but it's unique almost globally. There's only 5 or 6 other types of deposit where these minerals occur.
Arriving at Hope's Nose, we're surrounded by towering walls of Devon's signature limestone. As a sedimentary rock, the limestone began life, just like the slate, on the bottom of an ancient sea. But this rock isn't compressed mud, it's the remnants of trillions of tiny sea creatures.
When they died, their calcium carbonate shells sunk to the seafloor, and over eons, they cemented together, and that built up the layers that we see in these rocks. And so what you see here is a look back in time at the marine fauna that lived sort of 390 million years ago.
Judging by the fossil record, it was a very different sea from today's chilly English Channel.
So if you look here, Tony,
Oh, wow, that is incredible.
a fantastic fossilised seafloor.
These were all sea creatures.
Yeah, you can see these are remnants of corals that once flourished in the warm oceans.
It's extraordinary. It looks as though you ought to be able to pull them along with your fingers, but they really are part of the rock, aren't they? It just stretches all the way along, all the way along here. It's really spectacular. This evidence paints a picture of an idyllic scene. Warm, shallow seas, beautiful corals, and an abundance of marine life. But around about 300 million years ago, this tranquil scene came to an end when a supercontinent, which we now call Pangaea, was born. There was no English Channel back then, so what we now call northern France just smashed into what's now southern England, and the warm ocean thrust up huge mountains. This not only created the southwest coast, which we know and love, but it also started the process whereby hot gold-rich fluids eased their way into fissures in the limestone, and through this process, Devon's unique gold was born. This process, known as seismic pumping, continued for millions of years, bringing more and more gold to the surface. But what I want to know is why the gold occurs in its distinctive fern-like formation rather than just as a lump or a nugget.
The gold was crystallised very, very quickly. If you imagine it was a very cold morning in your car and you put the water on the windscreen, it suddenly becomes fern-like very fast. And that's exactly what happens with the gold here. The fluids are enriched in gold, come to the horizon, they're suddenly cooled, and they've done exactly the same thing. They've just turned into fern-like forms.
Just like at the mine in Wales, the gold here is virtually invisible to the naked eye, trapped in veins of rock-hard calcite. It's only when the rocks dissolved away with the strong acid that the full beauty of Devon's gold is revealed. This is so exquisite. It's one of Russell's original specimens. As you can imagine, this is worth thousands of pounds now. And when people first heard that there was gold at Hope's Nose, there was a sort of mini gold rush. But you can't dig a gold mine here, so people started improvising, didn't they?
They used rock picks, hammers, and as you can see here, this is Russell's original vein that you get the specimens from, and someone's come down afterwards with a big drill and tried to extract some more of it.
So the whole rock face is under threat now, isn't it?
Yeah, absolutely. What we're trying to do now with this deposit is to try to rescue what there is here for the national collection so we can research how the gold was actually formed.
For Alan and his team, today is the culmination of over 18 months' work, as they're about to extract one of the last known specimens of gold.
So for the past year and a half, we've been on our hands and knees for hours a day with hand lenses looking for gold, trying to ascertain if there's any gold left on the deposits.
Did you find any?
Yes, we have. If I skip over here, I can show you that this small black spots, this small rib here,
Yeah.
is actually native gold in calcite. So if I give you a hand lens, hopefully you'll be able to look at that closely and you'll be able to see one of the only few places in the UK you can see gold actually in situ in the rock.
I don't know how anyone could possibly identify that with a naked eye.
Once you get your eye in, once you can see it, it's very easy to do. We don't really know whether it's just a small blip at the surface or whether the gold actually goes deeper than that and it's actually a very large sort of pod type deposit.
That's really tantalising, isn't it?
Yeah, absolutely.
So it could be absolutely minute, or that might be just 1,000th of it. It's amazing to think that this gold has been locked into these rocks for over 300 million years. Yet with the aid of a diamond-tipped chainsaw, it's free in about 3 minutes. But I can't deny I am a little disappointed, because to me it still looks like a bit of rock. Though Alan seems pleased enough.
It's fantastic. You always have this romantic view of I'm going to take the rock out and there'd be this fantastic gold specimen, but in reality the gold is locked up inside the calcite itself.
When the rock's finally dissolved away, Alan's hoping that this is what will be revealed. Stunningly beautiful, almost magical gold that's been locked into the Devon rocks for millennia. Even then, this will be just the start of his investigations.
The whole point about this extraction was not only to preserve the gold, but to look at the mineralogy as a whole. We can look at the sort of the fluid that formed the gold. We can do some geochemical work, and hopefully that will shed more light on how this unique deposit was formed.
So no more gold, but plenty of geology left.
Absolutely, yes.
The gold we found today will be preserved by the Natural History Museum for the nation. Oh, but I should tell you that the deposit here is virtually exhausted, so please don't come roaring down with your rock saws and your explosives. But as the price of gold soars, so prospectors are on the lookout for fresh deposits. And Britain is on the verge of a new, highly lucrative gold rush. So for my final leg, I've come here, to the hills of Northern Ireland. Ireland has a long tradition of gold which may date back over 4,000 years. Many think these early Bronze Age artefacts are made with gold that was found here. But my journey is bringing me bang up to date with a modern gold rush that looks set to turn the Emerald Isle gold. It wasn't until the 1960s that scientists finally figured out that it was something called plate tectonics that had shaped our planet. The theory said that all the Earth's continents had moved slowly across the face of the Earth, colliding and splitting throughout geologic time. They then went on to figure out that if Northern Ireland had once been joined to a gold-rich part of North America around Newfoundland, and as the rocks in both places were the same, then if there was gold in North America, why not here? I've come to the Curranaut Prospect near Omagh to meet a man who's been hunting for gold here since the early 80s. His search has seen him scour every inch of these hills. Garth Earls is a senior geologist of the Northern Ireland Geological Survey. And it was in this slippery stream that he and a colleague made an exciting discovery. Garth wasn't panning for gold. He was looking for something much more surprising. Rust.
And that material is probably caused by the occurrence of the minerals that contain gold, specifically what minerals known as fool's gold. So some places where we see this particular iron oxidation, this iron material, we can sort of figure that this might be a good place to look. Hopefully you can see some of the fool's gold.
Oh yeah, I can see that with my naked eye, yeah. Fool's gold is the nickname of the common mineral iron pyrites. And while it looks like real gold... Oh yeah, yes, it's full of it, isn't it?
It is.
Often, it's a worthless dead end for prospectors. But Garth discovered that in this deposit, the fool's gold occurred along with the real stuff. So it could lead him to a bonanza.
The more pyrite that's present in this rock, the more gold is present also.
So there might even be tiny little flecks of gold in there?
Oh, there are.
So what do I do with this?
Well, you can keep it or you can throw it away.
Seems a bit wanton, doesn't it? There's gold in there. Although Garth's cavalier attitude may be well-founded because he'd discovered something else. He noticed that this stream seemed to bend and meander in a number of places, and wherever it did, he found veins of quartz loaded with both fool's gold and real gold.
The stream can't break through, it can't go past this, and it follows it for about maybe 15 or 20 metres, and then it changes direction again. So if you look at this on a map, you will see the stream has got these meanders, and every one of these meanders turns out to be associated with a gold vein. Bash these rocks.
So this is the big place. This is where you first knew that you were on the money.
We can take this and crush it down. It's very rich, contains very high levels of gold.
So in here, there is actually gold that was found in an Irish stream.
Correct.
It's very exciting, isn't it?
It is, and that's the same buzz as prospectors and geologists we get whenever we find something like this. This is what we spend our time looking for, and to be successful and find it gives us a real kick.
But of course, just because they'd found the quartz veins, that didn't mean that a mining company was suddenly going to stump up the millions of pounds that would be required for a major mining operation. In order to get that kind of evidence, they needed to go underground. This way?
Yeah, down the stream.
This exploratory tunnel, or adit, was dug as the result of Garth's findings. Running directly under the stream, it extends deep into the hillside. This tunnel's a huge piece of engineering. Why was it necessary?
Because we needed to prove that the veins were continuous. Here we're actually travelling along the vein, and we can see that it's well mineralised. We can see that it's continuous, and that gives us a lot of confidence. And just along there, you can see that the vein is almost all made up of iron pyrite, this sulfide, that contains the real gold.
It's a big one, this, isn't it?
Yeah, the vein's just over 1 metre wide here, and the grade is exceptionally high. I mean, this material contains over 10 ounces of gold per tonne of rock.
But as the old saying goes, all that glitters is not gold. So as pretty as this is, the shiny stuff is the worthless fool's gold. The real gold is invisible to the naked eye. Microscopic particles 20 microns across. That's about 1/8 the width of a human hair. So any mining operation would need to first extract and then crush up the rocks to create this. Gold dust. It's a huge amount of work, but it looks like the rewards might be worth it. This rock contains about $10,000 worth of gold, and the mine manager said to me that anyone can have it provided they can take it away, which is very generous, except it weighs the best part of a tonne. I'll come back for it later. In fact, Garth and his team have estimated that in this hillside alone, there's at least an incredible 600,000 ounces of gold, which at today's prices is worth about £500 million. But mixing my metaphors, even that's probably just the tip of the iceberg.
The information is that the resource of 600,000 ounces is in the central portion of this map.
But you've got an enormous number of other veins over there, over here, down there.
Yeah, there's over 30 veins have been discovered. The resource itself is only based on 6 or 7 of these. As well as that, this area here has a lot of potential. This area here, and down to the south also.
Do you think there could be as much gold there, there and there as there seems to be here?
Yes, there's every reason to believe that if the same amount of work is successful in the west and the south and the east, that 600,000 ounces can be significantly increased.
That would be an awful lot of gold in one hillside. This potential bonanza led to Northern Ireland becoming the most widely surveyed country on the planet. Called the Tellus Project, for 3 years, every inch of Northern Ireland was studied from the ground and from the air. What it revealed was this. A kind of treasure map for the 21st century, with the darker areas or bullseyes identifying the locations richest in gold. But deciding where to dig is a difficult and expensive process, as the grade of gold and type of terrain dictates the method of mining. To date, only one location has been granted the licence to dig, and with the potential of a massive 14 tonnes of gold hidden in the deposit, it's no surprise that the diggers and haul trucks are already hard at work in search of microscopic gold. My journey to unearth Britain's gold has taken me the length and breadth of the country. And this is my final stop, a large hole in the ground deep in rural Northern Ireland. This is Cavanagh, Britain's newest and only working gold mine. And all right, a great big hole in the ground isn't everyone's choice for a visit, but this is where our story comes to a fruition. Because although my search for gold is over, nature doesn't give up its treasures that easily. How on earth do you mine something you can't even see? The answer is a multi-million-pound operation burrowing deep into the landscape. But there are no tunnels here, as this is an open cast mine. And they have to dig a hole this large just to get at a vein of gold-bearing quartz a few feet wide. Nick Hardy is the man in charge. How much rock do you shift?
We need to shift round about 60 to 70 tonnes of rock to get a tonne of ore material.
And how much gold will you get out of that 1 tonne of ore?
Our ore that we deliver to the mills running around about 7 grams per tonne.
And what can you do with that?
7 grams of gold for an 18 carat gold wedding ring.
So that's 60 tonnes of rock to make one wedding ring?
That's right.
Extracting the ore is just part of the process, as the precious invisible gold still needs separating.
We've got the ore coming in over here.
And to do that involves a lot of industrial crushing, smashing, and finally bubbling through these flotation tanks, which use the gold's hydrophobic or water-hating properties to separate the gold particles from the other minerals. And when it's all done, they get this: a bag of purest grey? What's in there?
Well, it's a mixture of minerals just as it was in the vein, but in a more concentrated form. Pyrite in its various forms, lead and gold and silver.
These bags are destined for Canada, where the gold will finally be separated. But to test the purity and grade of what they mine, the guys here carry out a test called a fire assay. Fire assay means trial by fire. It's a pretty appropriate name because this furnace is over 1100 degrees centigrade. As dangerous as this test is, it's vital, because not only does it determine the purity of the gold, and therefore how much the mine gets paid, but it's also the only time they ever get to see their gold here at the mine. So there you have it. Pure British gold. More than 400 million years in the making, and now fueling a new gold rush. Since operations began, the mines extracted over 15,000 troy ounces of gold, which at today's prices is well in excess of £100 million. But not all the gold's exported. Some of it's used to create their own brand of jewellery. Jewellery made with rare, pure British gold, just as the ancient Celts are thought to have done over 4,000 years ago. From fiery origins in an ancient sun, formed by millions of years of violent tectonic forces, searched for by hopeful prospectors for millennia, gold is one of Britain's true treasures. And despite the Earth not giving it up easily, this magical, indestructible metal has shaped our landscape, our economy and our history ever since the birth of Britain itself.